Hello there! I am Mr. Chomar. For today, I will be your digital teacher. For this video, we will share new learnings in Mathematics 7. Let us make math more fun and exciting. So what are you waiting for? Let's get started! After going through this activity, you will be able to determine between what two integers the square root of a number is. Direction for this activity: find the principal root of the given number. Number 1. Square root of 121 is 11. The principal root of 4 is 2. The principal root of 20 is 4.4721, and so on. Number 4. The principal root of 34 is 5.8309, and so on. For numbers 3 and 4, its principal roots are irrational, since these numbers are not perfect square numbers. In this lesson, I will teach you new skills about estimating its principal roots of non-perfect squares. Estimating is very important for all principal roots that are not roots of a perfect square. There are just 3 steps in determining between what two integers the square root of a number is. First step, determine between what two perfect square number does the radicand lies. Second step, find the roots of those two numbers. And the third step, the conclusion. Example, we have square root of 20. First step, determine between what two perfect square number does the radicand lies. Our radicand here is 20. As you can see, the numbers listed in the number line are perfect square. Using the number line, we can somehow illustrate and locate between what two perfect square numbers does the radicand 20 lies. The two closest value of 20 that is perfect square is 16 and 25. Second step, find the roots of those two numbers. Square root of 16 is 4 and square root of 25 is 5. And for the last step, the conclusion, then we could say that square root of 20 is between 4 and 5. Another example, square root of 34. First step, determine between what two perfect square number does the radicand lies. To determine, let us plot it to the number line with perfect square numbers. So as we can see, the two closest value of 34 that is perfect square is 25 and 36. Let's go to the second step, which is find the roots of those two numbers. The roots of 25 is 5 and the root of 36 is 6. For the conclusion, we could say that the square root of 34 is between 5 and 6. Another example is square root of 120. First step, 120 is between the perfect square 100, which is a square of 10, and perfect square 121, which is a square of 11. So in the first step, we can say that the two closest value of 120 that is perfect square is 100 and 121. Second step, let us find the roots of the two values. Square root of 100 is 10, while the square root of 121 is 11. It's time for the conclusion. Then, we could say that square root of 120 is between 10 and 11. Last example, we have square root of 78. The closest value of 78 that is perfect square is 64, which is square of 8, and 81, which is a square of 9. So let's find its roots for the two values. Square root of 64 is 8, while square root of 81 is 9. So for our conclusion, we can say that square root of 78 is between 8 and 9. Very easy. With your knowledge and understanding from the activity, it is time to learn new concept. In the given review activity above, some items are considered as factor or roots of a perfect square number. A perfect square number is a number made by multiplying an integer or whole number by itself. For instance, 36 is a perfect square because it is a product of the same number multiplied by itself, which is 6 times 6. Now let's talk about square root. Square root is written with radical symbol and a number inside the radical symbol, which is also known as radicand. Let us consider this definition, square root of b times b, for us to easily find the square roots and that lead us to spot the principal root. Example, the radicand is a perfect square number. We have square root of 9. Square root of 9 are equivalent to two sets of integers, which are square roots of positive 3 times 3 and square root of negative 3 times 3. Square root of positive 3 times 3 is equivalent to 3 squared, square root of 3 squared, and square root of negative 3 times negative 3 is equivalent to square root of negative 3 squared. We can cancel the radical sign together with the exponent here. So it leaves us with the square roots of 3 and negative 3. Our principal root here is 3, since principal root is the positive root. Another example, square root of 36. Square root of 36 is equivalent to square root of 6 times 6 and square root of negative 6 times negative 6. So we have square roots positive 6 and negative 6, and our principal root, which is the positive root 6. Let's have square root of 16. Square root of 16 is equivalent to square root of 4 times 4 and square root of negative 4 times negative 4. Our square roots here, positive and negative 4, and our principal root is the positive root, which is the positive 4. And we are done. To sum up what we have learned, let's answer the fill in the blank questions. Read the paragraph and supply the missing term. Okay, let's answer. Number 1. A blank number is a number made by multiplying an integer or whole number by itself. What do you think is the answer? Yes, it is a perfect square. A perfect square number is a number made by multiplying an integer or whole number by itself. Number 2. Radical symbol is used to indicate the positive root or otherwise called as blank. Yes, you're right. It is the principal root. Number 3. Blank is very important for all principal roots that are not roots of perfect square. Yes, it is estimating. Estimating is very important for all principal roots that are not roots of perfect square. Number 4, in determining the possible square root of a non-perfect square number, the first step is to determine between what two perfect square number does the radicand lies. The test B, for what I have learned, enumerate the steps in finding the possible square root of a non-perfect square integer. What do you think is the first step? Did you still remember? Yes, the first step is determine between what two perfect square number does the radicand lies. The second step, find the roots of those two numbers. And the very last step, and very easy to remember, we call the third step the conclusion.